So I'm going to try to do an example over here and write the steps of the process over here, kind of at the same time. Implicit differentiation is when you have to take the derivative of something that you can't solve for y. So like, I could not get y by itself here and say y equals this. That'd be explicit. That'd be like explicitly saying, here's what y equals. Implicit is kind of assuming, well, y equals something. I just don't have the mathematical ability to find it. But it does equal something, and I can actually find the derivative without ever knowing the original equation. So like if I tried to square root the y squared to get y by itself, then this y would have a square root and I'd be kind of stuck. So you get these situations where you can't solve for y, but you got to take the derivative. So the first step, and I'll do it and then I'll write down what I did, is you're going to take the derivative of everything in here. But if you take the derivative of a y, you're going to multiply by dy over dx. It's like a chain rule thing. I don't want to get too much into like the y. I mean, I can talk about it some, but I'm going to take the derivative of each thing. But whenever I take the derivative of y, there's a chain rule involved in that, and I know that I have to multiply by the derivative of that y, which we're going to call dy over dx. So the derivative of 3x is 3. The derivative of 2y is 2. But if you think about it, y as being like the little guy, we don't really know what it is. But I'd have to do a chain rule and multiply by the derivative of that little guy, which is dy dx. Like, I don't know what y was, but I know the derivative of y is dy dx. So whenever you take the derivative of a y, you multiply by dy dx. What about the minus 4? What's the derivative? 0. Derivative of y squared would be 2y times dy dx, and then the derivative of 10 is 0. So your first step, take the derivative of everything. And then if you take derivative of a y, multiply by dy dx. I might run out of room here for the steps. That's your first step. And now it's just algebra, really. Like, I'm going to write the steps out, but it just turns into an algebra problem. We want dy dx by itself, because what does dy dx stand for? Derivative. So if I can get to a point where I can say dy dx equals this, well, that's the derivative. I never even really knew what the original y equals was, but I can still get to a derivative. So I'm just going to get all the dy dx's on one side, everything else on the other side. So in this one, that's just like moving the 3 over. So your second step would be gather all dy over dx on one side. It could be either side, doesn't matter. So if I had that, and I want to do dy dx by itself, what would your next step be? Do what? Not yet. Well, maybe. I don't know if you're doing this stuff in your head, but how do I get the dy dx by itself, or like out of the two terms? Yeah, I'm going to factor it or reverse distribute it, so I'm going to get dy over dx times 2 plus 2y. So like, Naomi, you're going to divide eventually, but I don't know if you were...
Yeah.
Okay.
I didn't like think of it that way, but I
Right.
basically did that.
So factor out the dy dx. And then your fourth step is divide. So at this point, I'm just teaching you algebra, but that's okay. Oops. So your answer here would be dy over dx equals 3 over 2 plus 2y. And that's your derivative. So at at this point I could say what's the slope at 2 comma 7 or whatever and plug in. It does get a little different because there's 2 variables now, so we'll just make sure we do that. But yeah. Oh, yeah, sorry, thank you. I kind of forgot my negative sign there. Thank you. Yeah.
Why do you use dy dx instead of like y prime?
Y prime works, but when I teach it with y prime, eventually one or many people will think it's a y to the 1, and like it'll screw up their work. I'm not going to tell you you can't do y prime. I'm just going to recommend dy dx.
Alright.
Fair enough.
Isn't f prime of x also equal?
Yeah, if you want to. Any other questions? All right. So these get a lot harder when we do like product rule and stuff, but we're not going to do that until tomorrow. Kind of do the basic ones today, and then move a little more tomorrow. And we have to learn to take the second derivative of these at times, which are cool. So that was a little tougher. It's just longer. It's not like the process is any different, just more of it. But same idea. So I'm going to take the derivative of everything. So 2x squared, the derivative is 4x. Derivative of 4y squared is 8y, but you took the derivative of a y. So multiply by dy dx. The derivative of 4x is 4. Derivative of negative 8y is negative 8, but you took the derivative of a y. So multiply by dy dx. And then 3 plus 21y squared times dy dx. So I said gather on one side. It doesn't matter which side you do. I want you to understand something about the answers, though. Hold on, Naomi. If you put them on one side, I don't know what the answer is, but let's say that I put them on one side and I get this as my answer. If you put it on the other side, if you put the dy dx on the other side of the equal sign, you would have gotten that as your answer. Understand that those two are the exact same thing. As long as every single sign is opposite, it's still the same answer. Now, if you start mixing them up and only half are opposite, you got a problem. But if you put the dy dx on one side or the other, you're going to get a different version. And as long as every side is opposite, you're good. Naomi, what was your?
Well, whenever you take the derivative of y, it's dy dx, and the next step is together. Could you just gather all the y's and all the x's on different sides first, and then take the derivative, or does that mess it up?
No, that works. But when we start doing product rule, it's going to be impossible.
Okay.
So I'm like cheating a little bit, knowing what's coming. So yeah, now I'm going to get all the dy dx on one side. So I'm going to bring them to the left. You can bring them wherever you want. So I'm going to put ay dy dx minus 8 dy dx. And then it'll be minus 21y squared dy dx, right? Because we got to bring it over. The 4x will go over there, so it'll be negative 4x. 4 goes over there, so it's negative 4. And that 3 was already there. And so we could have actually combined some like terms before we even started. I didn't even notice that. But like right here, I can just make this negative 1 now. So I'm just moving that over here, then combining those, I get negative 1. What's next? Factor. So take out my dy dx. And I'll get 8y minus 8 minus 21y squared. Everybody's good with the dogs? Everybody still here? Didn't fight any of your drugs?
We'll see.
So divide, you get that. How many worked out of me and you already had this answer? Okay. Questions on anything I'm doing there? So one thing that's different, that's not different, it's just like a little extra is, so if I said, find the slope at 1 1, comma 2, and I don't know if 1, comma 2 is actually a point in here or not. I'm just making it up as an example. Normally, like when we did derivatives before, they just had x's in them, so you would just plug in x, right? Well, now your derivatives might have y's in them also. So if I had said find the slope of 1, comma 2, you have to put a 1 in for x and a 2 in for y, and just do the math. I mean, it's just like an extra number. But. Questions on that? Anywhere? Not bad, right? Tomorrow it gets a little more in depth, I guess, but it's still not terrible. Let me give you one to do without me rambling on. So I'll say find slope. I have no idea if this point is on that line. Just bear with me and let's just pretend it is. So go through, find the derivative, plug in, and get your slope, and let's see what we got. Question? Not enough for that. You're right? No calculators. I don't know if that's what you're doing out of that. Well, could you make it so you didn't have to do 12 times 9? Or, you better learn how to do 12 times 9. Those are your options. So just let me, yeah, did I screw up? What?
In the simplified version,
Yeah. Thank you. Is that what you were going to say too? Okay. So a couple things just to show you what I did. This is an acceptable answer. Like you're done at that. Well, actually before that, I also skipped 2 steps, right? Like I skipped the gather and the divide, but I think you'll get to that point fairly quickly. Where, and if you don't, you don't. It's up to you. But these 3 things are going to be factored out, or those 2 things, I guess, are going to be factored out, and then where are they going to end up? They're going to end up on the bottom, and somebody that's going to divide. So I skipped that stuff. You're welcome to. You don't have to. You know, if you're skipping it and getting it wrong, you probably should stop. Second thing, you're perfectly welcome to stop here on a free response. On a multiple choice, they would probably do this, so you have to match it up. And I did this because I have to plug in numbers. So So like Quinn was saying, like, I don't know 12 times 9. Okay, well, do you know 6 times 9? Like, if we can reduce it, we can make our multiplication lower, you know. So you can reduce to make your life easier. So this one must come out to like 10 over 1 or 10 over 84. And that's okay too. Like, those are both acceptable answers. On the multiple choice AP test, they'd probably put that. But if you got this, you know, I'm fairly certain you can just cut them both in half and get where you need to be. Questions on anything up there? Alright. Tomorrow we'll do, because they do get involved with like product rule with us. And then second derivative stuff. I think it's downstairs. Yeah, I gotta go. Wait, no, I don't. Sorry. Oh, yeah. I'll be back in a minute. I applied for teachers in America, you know that? We had to give like a 5-minute lesson on whatever we wanted to, and that's what I did. Tomorrow. Remember your Khan Academy is due tomorrow. You haven't started it yet? There's a lot. Christine, I think?
Some of those are just so frustrating.
If I'm being completely honest with the con, there's 0 chance I'm checking it on the weekends. So I'm saying, you know, it's due Friday, but I really probably won't look at it until Monday morning.
Yeah, but you'll be able to see if we connect it late because Con has a lot of today.
I will, but if it's in by Monday morning, I'm not gonna hold out against you. Yeah, I mean,
Well, I'm doing this planning, taking down until the I was like,
So yeah.